Welcome. Today we're going to learn about exponents. And we have some exponent rules. First of all, in item 1, x to the 0 is equal to 1. Anytime you have a variable raised to the 0 power, the answer is 1. In item 2, we have x to the minus 3 is 1 over x cubed. When you have a negative exponent, it does not mean that the term is negative. Basically, you want to use that negative exponent to simply move, in this case, x cubed, from the numerator to the denominator. And if you look at item 3, we have 1 over x to the minus 3. Now you have a negative exponent in the denominator. Now we're going to do just the opposite. We're going to move x cubed from the denominator to the numerator. So think of the negative as just kind of a switch that moves the x to whatever power from the numerator to the denominator or the denominator to the numerator, back and forth. And here are some more rules. So in item 1 we have x squared times x cubed. Now here we have a common base and we're multiplying. So when you have a common base and you're multiplying, you want to add the exponents, so we wind up with x to the 5th. In item 2 we have a common base. Again, x is our base. The difference is here we're dividing. So when you divide common base, you subtract exponents. So you wind up with 3 minus 2 and you get 1. And here are a few more examples. In item 1 we have x squared raised to the 3rd power. So when you raise something to the 3rd power, in this case, what you want to do is multiply the exponents. So you wind up with x to the 6th. In item 2, we're simply moving from a radical form to an exponent form. And when you have a situation like this, first of all, you have x squared. Whatever the exponent is underneath the radical, that winds up in the numerator. The 3 winds up in the denominator. So remember which one winds up in the numerator and which one winds up in the denominator. A good way to kind of have a memory jogger here is if you look at item 3, most students know that the square root of x is x to the 1/2, and if you have that memorized, think about the exponent underneath the radical. Well, it's 1 because it's x to the 1, and that winds up in the numerator. So that kind of helps you remember where they wind up. So let's work out an actual example where we have to simplify. So in example 1, if you look at the terms, we want to change the radical x, square root of x, and we also want to simplify the denominator. The other terms appear to be okay. So if you move to item 2, again, take it term by term. So the first term we're not going to change, second term not going to change, but the third term, square root of x, we're going to replace that with x to the 1/2. In the denominator, x to the minus 3 squared, you're going to multiply those exponents and wind up with x to the minus 6th. Then when you move down to step 3, at this point what you're going to do is that denominator, remember what we said, when you divide and you have a common base, you subtract exponents. So the denominator, x to the minus 6, that can be divided into each term in the numerator because the terms are all separated by pluses and minuses. You can divide them into those terms. Think of it as kind of, right now it's a common denominator, but you can really break this up into 3 fractions if you think of it that way. So in the first situation, first fraction would be x cubed divided by x to the minus 6. So what do you do with the common base? You subtract the exponents. So you wind up with x cubed minus a negative 6. And if you follow that pattern with the other 2 terms, you have what you have in item 3. In item 4, you simplify. So 3 minus 6 is 3 plus 6. So you get x to the 9th, and you can continue down the line there. And then in the last step, in step 5, we're going to change the third term from x to the 13/2 to the square root of x to the 13th. And those are exponent rules. Now go practice, practice, and practice some more.